This is the midterm review, page 6, and we're just going to do problem 17C because problem 17A and B have been done already on a previous video. Okay, so problem 17, it gave us some information and about the mean and the standard deviation, and that information also holds true for part C. So let's just get ourselves set up. Oh my God. The scrolling goes crazy. Okay, so my pens. All right, what the problem has told us above, if you just look on your paper where it says number 17, it tells us that there's research being done into the number of days it takes for a business license to be issued, and the scores, the number of days it takes for the license to be issued, are normally distributed with a mean of 45 days. Okay, so a mean of 45 days and a standard deviation of 4.1 days. So I'll write that up here. Our mu is 45 and our sigma is 4.1. Okay, and the question asks us what percent of business licenses would be issued between 40.9 and 49.1 days. Now, there are two ways to do this problem. There's a very, very quick way to do it, which most students seem to not really understand. And there is a longer way to do it, which students seem to understand. So I'm going to do it the longer way, and then I will explain the quick way at the end. Okay? So we want to know the percent of data that is between 40.9 and 49.1. All right? So the question is asking us, we want to know this whole area of the curve that I'm going to stripe. Okay? The area between those two numbers. Now we should know, if we have been doing the work of the class, that the first step in this problem is to standardize. Z equals x minus mu over sigma. Okay? So we have two x values. They gave us an x value of 40.9 and they gave us an x value of 49.1. So we've actually got to do this 2 times. So I'll write the formula twice because I like to set it up kind of in 2 columns. Okay, so my first z value is going to be 40.9 minus 45 over 4.1. Okay, and then the second z value is going to be 49.1 minus 45 over 4.1. Now, when we work this, we're going to find that this gives us a z value of -1. And this calculation is going to give us a z value of +1. Okay? So, you know, we always have to keep in mind that what we're doing when we standardize, we're mapping these normal distribution values onto the standard normal, which is a theoretical distribution that always has a mean of 0 and a standard deviation of 1. Okay? So what we've found is that this x value of 49.1 is equivalent to a z value of +1. And this x value of 40.9 is equivalent to a z value of -1. Okay? So, what we need to do now, we finished the first step, which is standardizing. Now our second step is finding the p-values. Okay, and where do we find the p-values? Well, we look on our z-table. Okay, so I'll look on my z-table, and I want to find the p for a z of 1.0. And here it is, 0.3413. Okay, so let's write that down, 0.3413, and this also 0.3413. Okay, let's make sure that we know what this means. Okay. Remember, the p-value is the area between the z, okay, our z is equivalent to this, and the mean. So this p represents this part of the curve that I've shaded in green. Okay? I notice that my minus has disappeared. That's a very annoying thing that this stylus likes to do. Okay, then this p-value, we'll use blue since students got mad in class for me using non-manly colors. Okay, actually that was my engineering group, not a statistics class. This area is equivalent to this. Okay, and just to drive the point home just a little bit more, you know, in standardizing, that is what we have found. Okay, so the question wants to know the area between this value and this value. Now, if you understand the characteristics and you followed my explanation, it's very logical that what we're going to do is we're going to add the two p-values, and that's the you could call it a formula that you follow when you have z-values with mixed signs. Okay, you have a negative z-value and a positive z-value, and it's a between question. What you do is you add the p-values. Okay, when z-values have mixed signs. Okay, so all we're going to do is take 0. What am I doing? That's because somebody ran by outside the window and I was momentarily distracted. Okay, we're going to take 0.3413, we're going to add them, plus 0.3413. And those two numbers sum to 0.6826, which is approximately 68%. Okay? Now, as I mentioned at the beginning when we started this is the long way to do this problem. Okay? The short way to do the problem, which most students, they actually hate it when I explain this way in my experience. Okay? You know, whenever you have a between problem, you should take a close look at the numbers, okay, to see if they follow the empirical rule pattern. Okay? Remember the empirical rule, which I learned as the 68, 95, 99.7 rule. Okay, it tells us 68% of the data is between mu plus and minus 1 sigma. 95% of the data is between mu plus and minus 2 sigma. And 99.7% of the data is between mu plus and minus 3 sigma. Okay? So if we look at these two numbers that this problem gave us, 40.9. Okay, look at our mean. Our mean is 45. Okay, our standard deviation is 4.1. 40.9 is equal to 45 minus 4.1, isn't it? So that's mu minus 1 sigma. Let's see if the other number follows the same pattern. 49.1, well, yes, that is equal to 45 plus 4.1. Okay? So you can see that the two numbers given in the problem, well, they follow this rule. It's mu plus 1 sigma, mu plus 1 sigma, yeah? And the other number is, sorry, what am I saying? This is mu minus 1 sigma, okay? And the other number is mu plus 1 sigma. So if you know the empirical rule, you know, and you have an eye for patterns, okay, you could just answer this question. You know, you could just say 68%. And then you could just write empirical rule. Empirical rule. Now, as I said, in my experience, most students like to do it this way. Okay, they find the empirical rule, I don't know, they don't like the empirical rule. So guys, either way is fine. You can do it the worked out way. Remember, you should show your work because you will get points for each step. Or you can do it the one-step empirical rule way. Okay, so that is question 17C on page 6 of the review.